Hi everyone! So ladder problems are very famous Pythagorean theorem questions, and you will see them many times in school, so this is your chance to get to know them, make friends with them. Alright, so here we have a ladder that is 10 meters tall, and we have to find out how far the ladder shifts up the wall when you move it closer to the wall. So this is the distance that we're trying to find here. This distance here. So first thing we want to do is find out exactly how far up the wall is it to begin with. So we're going to treat this like a triangle. Here it is, our right triangle. There's our right angle right there that the wall makes with the ground. And what do we have here in terms of the Pythagorean theorem, which I'm just going to write down? A squared plus b squared equals c squared. Where is the hypotenuse? So the hypotenuse lives across from the square angle, so it is our ladder. It's 10 meters. And we also know that it is 6 meters away from the wall, so we know this bottom length here, but we do not know this upper length here. So I'm going to plug in some numbers into our Pythagorean theorem. I'm going to call the bottom length A, so I will say 6 squared plus, I don't know the height, so I'm actually going to call this height here, I'm going to call this height 1. And then the second height, I'm going to call that height 2. So the second height is going to be this whole height from the very bottom to where the ladder is going to go, height 2. But we're not there yet, so let's just look at height 1. So then I've got height 1 squared, and is equal to c squared, which is our hypotenuse, and is valued at 10 meters, 10 squared. So let's solve this. 6 squared is 36, plus I don't know what height 1 squared is, and that's equal to 100 squared, which is, 10 squared, which is 100. Okay, so I need to find height 1. I'm going to subtract 36 from both sides, and I will get height 1 squared is equal to 64, and I will take the square root of both sides, and I find that height 1 is equal to 8 meters. So I've found that out, and now I need to find the second height. Now what information do I need? Now I'm looking at this triangle here. I'm going to color it in blue. So I don't know how high it is up the wall. I know that it is 10 meters long, and that's my hypotenuse. Do I know the bottom length? Do I know how far away it is from the wall? Well, I know that I moved it 3.2 meters closer than it was before. So what I need to know is this distance. And if it was 6 meters away before, and it is 3.2 meters closer, then I can just go ahead and subtract 3.2 meters from 6 meters, and I will get 2.8 meters. So I know that this distance here is 2.8. Now I have enough ingredients to do the Pythagorean theorem. I'm just going to scroll down a bit so we can see better as I'm writing in white. Okay, so a squared plus b squared equals c squared. Once again, I'm going to call that bottom length on the ground my a, so I'll put 2.8 squared plus height 2 squared, and that's going to be equal to 10 squared. Once again, the length of the ladder has not changed. So 2.8 squared, it turns out, is 7.84. I don't know what height 2 squared is yet, and once again 10 squared is 100. So I'm going to subtract 7.84 from both sides, and what I get is height 2 squared is equal to 92.6 16. And if I take the square root of both sides, I find out that height 2 is equal to 9.6. That's a decently nice number. Now, have we finished the question? No. Because what we needed to find out was how far does the ladder rise? Now we know how high it was at the beginning and how high it was at the end, but how far did it really go up? So what we need to do is take our new distance, 9.6, and subtract our old distance or height, which was 8 meters. And that is equal to 1.6 meters. So the ladder rose 1.6 meters when it was moved 3.2 meters closer to the wall.